After learning embedded C++ programming
with my Arduino series of projects and putting that to use when building my first robot with my dual mode robotic RC car,
I wanted to take my robotic skills to the next level by adding IoT capabilities to future robots. That's where this Esp32 project comes in. Completed in January of 2024, this web control LED system bridges the gap between the microcontroller programming and web development I learned in previous projects. This project transforms an Esp32 into a standalone web server that hosts its own Wi-Fi network and serves a custom web interface, built using C++, HTML, CSS, JavaScript, and WebSockets. I can control an LED in real time from any device connected to the Esp32's network. This project gave me essential skills in network programming, asynchronous communication, and IoT device architecture. All critical skills for building robots that can be monitored and controlled remotely. In order to build this project, the hardware requirements are minimal but goes as following. An Esp32 development board. This is the brain of the operation, where my software runs, capable of Wi-Fi connectivity and running a web server. This is where all my code runs, and this controls the LED. You also need a single LED with a current limiting resistor, which is connected to pin 4 on the Esp32, as well as a wire for ground and a breadboard to connect the Esp32 and the LED together. You also need a USB cable for powering the Esp32 and serial debugging, and a client device, basically any phone, tablet, or computer with Wi-Fi to connect to the Esp32's access point. The hardware of this project is super simple. The system operates in two layers that work together, the back end and the front end. On the back end, written in C++, the Esp32 creates its own Wi-Fi access point that you can connect to from any device. It runs an asynchronous web server using the Esp async web server library, which means it can handle web requests without blocking other operations. Simultaneously, it runs a WebSocket server for real-time, bi-directional communication between the web interface and the microcontroller. When you connect to the Esp32's Wi-Fi network and navigate to its IP address, the microcontroller serves an embedded HTML page with CSS styling and JavaScript functionality. The JavaScript establishes a WebSocket connection back to the Esp32, creating a persistent communication channel. When you click the toggle button on the web page, a message is sent through the WebSocket, the Esp32 receives it, and then changes the LED state. So the front end is in this index.h file and is actually stored as a string literal in this HTML content variable. So here we just have the boilerplate for the HTML, just like stuff that you have to have. This is the title for the website when it pops up in like a tab. Here we have the actual body with the elements. So it's just a big div with H2 and then a little div with a button in it and something that keeps track of the state, which basically just switches back and forth. So here's the styling. You saw the website, so that's just basically what the styling does. It just makes the website look the way that it looks. And here we have the JavaScript, which actually adds the functionality. Here we have an LED state variable, which just holds state of if it's on or off. Then this is just basically the elements that we wrote in HTML. We're selecting it using the document object model and the document query selector. So one to change to display the state, and one to check if we're clicking. And this is a WebSocket, which is basically on the window.location host, which is basically wherever it is, which would be the IP address. And this is port 81, and it's on port 81 to connect to the WebSocket server, which is hosted on the back end, which we'll get to later. And then this is just a function to change the state, and this actually adds that function on the button. So whenever you click it, it calls this function, and then it sends the state over through port 81 on the WebSocket server, and then it closes up because remember this is a string literal. So then on the back end, which is written in C++ using the Arduino framework, we have just the necessary libraries, and with that we include that index.h file that holds this HTML content variable, which holds all of our web content. So these are the global variables. This is the previous state. This is the SSID, or basically just whatever it will pop up as the Wi-Fi when you set up the access point. This is the password to the Wi-Fi. This sets up just the asynchronous server that hosts the web content, and this sets up the web socket server that actually communicates to the front end. This is just printing gaps to make everything look pretty. This is to print where you're connecting to, so it uses that, and then it prints connect to the SSID, which I said is just whatever it will pop up as for the Wi-Fi. Wi-Fi connect calls that print connection alert, the function right here that displays the SSID, and then it tells the Esp32 to go into Wi-Fi access point mode, which creates its own Wi-Fi. There's another mode where you can set it up as a station and have it on your home Wi-Fi, so it doesn't display its own Wi-Fi. You connect your home Wi-Fi, then you can navigate to its IP address and it'll still display the web content the same. But when you make it an access point, the Esp32 can independently host its own connection and you can be able to use it anywhere, not just at your home. So that's why I have it set up to that. And then this actually serves the HTML content that's stored in this index.h. So basically, it gets a request, blah, blah, blah. It prints out to the serial monitor that I got a request. It puts the HTML content into a string, and it sends it out, and then it also tells it that it's HTML. This also begins the server, and this serial prints the server's IP address, and this basically is the IP that you type in your web browser to navigate to the HTML content that it serves. So this actually reads the WebSocket event. These are like switch cases, so like if you're disconnected, it just prints the serial monitor you're disconnected. If you're connected, it gives the client IP blah blah blah, and it prints connected blah blah blah. And then this is if it receives text blah blah blah, you get it as a payload, then you convert that payload into a string, and then from there you print out that received text, and then you check if the received text is not equal to previous state, and if it isn't, then previous state is equal to the received text or whatever you just got. So this actually checks what the received text is after you set it to the previous received text. So if it's true, you set pin 4 to high, which basically turns the LED on because it's on pin 4, so it's on high. And then if it's not true, then it's off. So you set pin 4 to low, and then the LED is off, and then you break, and that's basically how it handles it. This is the setup. So basically this runs like initially whenever you first boot it up. So I start the serial monitor at this baud rate, and then I set pin 4 to an output. I digital rate pin 4 to low to turn the LED off. Then I run the Wi-Fi connect function, which basically does all the stuff we went over earlier. I start the WebSocket, and then I run the WebSocket function, this WebSocket event. On any event that goes through the WebSocket channel, that function runs and basically just turns the LED on and off, and then this serves the actual HTML for all this to go. And then I just loop the WebSocket to constantly check and run this function for any text. And that's really it. So it's 101 lines of C++, and then about 96, 97 lines of front-end code of HTML, CSS, and JavaScript.
This video is already long enough, so here are some challenges overcome and skills demonstrated. So that's my web controlled LED project built with the Esp32. Now for my next projects, I actually delve into a whole different lane and start working with computer vision and OpenCV.